So continuing on with correlations, we can see that an example of a positive correlation, right? Here you can see that the data is pointing upward if we try to draw a straight line through it from left to right, and that's why this is a positive correlation. And the data doesn't perfectly follow a straight line, but if we were to draw a straight line, the the data falls pretty closely, pretty consistently along that line, and that's why this correlation is much closer to 1 than it is to 0. Here we see an example of a negative correlation, right? Again, if we try to draw a straight line through this data, it would slope downward from left to right. And the data, once again, falls not perfectly along a line, but decently close to it. So it's closer to -1 than to 0, the actual value of the correlation. And finally, here's an example of a correlation of basically 0, right? Negative 0.02. That's pretty close to 0. And it's not even obvious how we should draw a line through this. If we were trying to draw a straight line, should it be like this? Should it be like this? Should it be like this? Right? Very unclear. And that's why we say that this is a correlation of near 0, no clear linear relationship between x and y. All right. Now, the other tool that we said we can use in particular if we have two quantitative variables, but really regression is going to be a broader framework we'll see in future lessons that can be applied also with qualitative variables often, but we'll start with quantitative variables. Regression is going to be a very powerful tool. And for regression, we're going to need to first make sure we're able to distinguish between our independent and our dependent variables. What do those terms mean? Well, an independent variable is a variable that affects or explains another variable, while the dependent variable is the variable that is being affected or being explained by another variable. So, up till now, we haven't worried about, if we're trying to talk about an association between two variables, do we think that one causes the other? Well, that's not something we've alluded to until now, but now we may want to start to think about a little bit, do we have one that we think comes first or is potential cause of the other? Now, sometimes we don't know. We don't have a clean idea about causality. And this is more just about, for convenience, we think about sequence one coming first or using one to predict the other. But this is sometimes a conceptual distinction as much as it is something that we've really clearly been able to identify depending on the context. But the general idea is the independent variable is going to affect, explain, or predict the dependent variable. That's the framework we're going to be working under when we run regression normally. And more broadly, whenever we create graphs, the typical convention is that if we do have one variable we're considering to be our independent variable and the other one our dependent variable, we usually put the independent variable on the x-axis or the horizontal axis and put the dependent variable on the vertical axis. So something important to know when you're creating graphs. So here's an example of what a regression line looks like. This looks like a negative correlation because if we were to draw a straight line through this data, it would point downward. And here you can see just an example of a line being drawn through this data. And drawing a line through that data can be thought of as doing linear regression. So before we talk about exactly how to interpret a linear regression, it's good to do a little bit of review of some geometry that hopefully we learned earlier in life, maybe in high school, maybe in middle school. And maybe you recognize this way of writing a line, maybe working with graph paper, right? This is just an example coming from Wikipedia, but you can think about the slope as being measured as rise over run, right? We don't so much care about the details of this. I'm just showing this maybe to jog your memory because it tells us what format we need an equation in order to be able to describe a line. And like we saw in the prior graph, we're thinking about drawing a line through data, right? A line of best fit, we could say, to the data. Well, the way that we describe this line is going to require an equation, just like we learned in geometry. So we'll write that a little bit differently than maybe we did in math class, because typically we're not going to use m in regression to represent the slope. Instead, we're going to use b or beta or maybe beta 1 to represent the slope. And instead of using B to represent the intercept, it's more common that we're going to use an A or maybe even a capital A, not shown here on the slide, but that's what some textbooks use, or an alpha or a beta zero, right? So as I sort of note here in parentheses, unfortunately, not everyone uses the exact same notation, right? So there's multiple possibilities. And if you look at different textbooks, they'll probably use different notation. But this is some of the common notation. But the important thing is that this term is what we're going to call the slope. This term is what we're going to call the intercept. We're usually going to use, if we just use simple letters, we're going to use y to represent the dependent variable and x to represent the independent variable. And here's an example of how we might write the regression equation, right? So you can see it looks very similar to what's written up here, except we've changed the order of the terms a little bit. And now we're using b to represent the slope, a to represent the intercept, as opposed to m and b up here. Okay, once we have our regression line, how are we going to think about interpreting things? So usually we mostly care about what is the value of A, what is the value of B that was estimated by our regression, and we call A and B the regression coefficients. So if we tell Stata to run a regression, it's going to give us a bunch of output, but the main thing we want to focus on is the estimates of A and B, the regression coefficients. We usually care more about this coefficient, B, the slope, since it tells us something about how the two variables are related. And now I want to give you another cheat sheet, this time for how to interpret the output for B when we run a regression. So there's three things we're going to care about, and we'll see an example of what output actually looks like that we get from Stata or something like that in a moment. But before we do that, let's do a quick overview with our cheat sheet. So we're going to have three S's that we focus on: significance, sign, and size. So you'll want to memorize that. Anytime you see a regression, you want to think, what is the significance? What is the sign? What is the size? And let me show you just an example of what that actual interpretation is going to look like. Here you can see that this is the code to run a regression in Stata, but we need to actually copy that and paste this into Stata, which we'll do in just a moment in part 3 of this lecture. But once we get that output, we're going to be looking at the significance, the sign, and the size. With significance, there's going to be something called a p-value, and we want to know, is it smaller or is it bigger than 0.05? And that's going to tell us whether or not it's significant. If it is significant, then we often want to go back on to look at sign and size. But if we find that the p-value is greater than 0.05 and it's not significant, then usually we just stop there. We say it's not significant. Then we go on, if it is significant, to look at sign. We just want to say, is it a positive coefficient or a negative coefficient? That's related to the idea of something being a positive correlation or a negative correlation. And finally, we're going to look at size. How big is this coefficient? Is it a strong effect? Is it a weak effect? And again, these bullet points give a lot more details. We'll return to that in the future, but I'm going to mostly let you read all of those details on your own. And we will start in the next video of this lecture video series a example of applying these three S's when we run a regression.